numbers. You can't add decimals. You can't say, oh, I'll put 2.5 of that. Okay, it's either 1, 2, 3, they're whole numbers. And you can add a lot of these. I've seen equations in the past where we've had 25 of a certain molecule that has to be added. Because this comes down to something called common factors. You learned about that in math. Okay? And sometimes something's not going to necessarily work out unless you find common factors. That means you're going to have to change. Sometimes there are some things in some of these equations you might not even have to change. If you don't have to add a number, don't. But if you do have to add a number to everything, you've got to make sure that they even out. So in this case, how many chlorines do I have on my reactant side? How many do I have on my product side? So, first things first, I am going to add a number 2 here. Okay, because I want to even out the number of chlorines. So if I do that though, this number 2 gets multiplied by this guy and by this guy. So does it impact the number of actual sodiums? What does my number of sodiums become? So what I do is I leave that number there and I put a cross through it. Okay, and I'm going to write the new number next to it, like that. Okay, there are now 2 sodiums on the reactant side. What do I do to my chlorine? How many of those do I have now? 2. Okay, so that balances out. That's good, but there's an issue with my sodiums now. What can I do on the other side of my equation to make sure that I've got the right number of sodiums now? I can add another 2 over here. If I do that, I multiply by the first and by the second element in that molecule. So now how many sodiums do I have? 2. How many chlorines do I have on this side? So I'm good. I don't have to touch my chlorines. And now how many fluorines do I have? 2. Oh, look at that. Now, this is a balanced equation. Okay? This whole equation, if this reaction occurs in nature, you have to have that many of each of the molecules. 2 molecules of sodium chloride react with 1 molecule of difluoride or 2 fluorides, okay, yields 2 sodium fluorides and 2 chlorines or dichloride, okay? That is a balanced equation. Now notice how I didn't do anything to this F2 and I didn't do anything to the Cl2. You could write a 1 here. You can. You don't have to. Okay, it's up to you. If you find that that's going to help you remember that there's only 1 of those molecules, go for it. Okay, but you don't need to do that. This is how we balance an equation, and this is how we prove the law of conservation of mass. There's the same number of elements on both sides, and then there's the same number of atoms of each of those elements on both sides of the equation. So if we look at this equation, we see that it is in fact balanced. If I was to look at all of, my calciums, my chlorines, my sodiums, my carbons, and my oxygens, I would see that there's the same amount on both sides. Now, the interesting thing here is when I put a 2 in front of my NaCO3, I'm actually multiplying 2 times Na and 2 times CO3. CO3 is what we call a polyatomic ion, and that is just, it's a molecule, but in natural state, it's quite stable as it is. So the question is, you'll notice when I balance this equation, there was no bracket of CO3 on this side, right? There was no actual bracket here, but all of a sudden there's a bracket on the other side. And that's because we know that calcium over here has 2 valence electrons. Chlorine needs 1 valence electron, right? It's got 7. So that's why Ca is bound to 2 Cl's. Because the 2 valence electrons, one of them goes to one Cl and the other one goes to the other. Okay? The actual charge of a carbonate is also -1, same as chlorine. Right? Carbonate is a polyatomic ion, and then what ends up happening here, you cannot add a subscript, but what you are allowed to do in the case of polyatomic ions, okay, when things are comboed like that, is if you can treat this as one actual element. Okay? And that's why I've put a bracket here. That's why I've actually put a bracket and a little 2 beside the bracket, because this 2 right here deals only with the carbonate. It does not deal with the calcium. All right? When you're balancing equations, you won't need to do that. Polyatomic ions are an EST topic. They will not appear in your June exam. Okay, but for this actual example, this is a really good example of something forming a precipitate, of a chemical reaction. So for me to balance this, I just did this really quick. Okay, but you are allowed, that's the only instance where you're allowed to add actual subscripts, as if it's next to a bracket. You'll see that other polyatomic ions include hydroxide, which you just learned about for acids and bases. Okay, PO4, which is phosphate, SO4, which is sulfate, and NH3, which is ammonia. Okay, these guys here are your polyatomic ions. So they're treated as one actual element. Okay, they have one charge for the whole molecule.